Hi, everybody. It's Professor Mitchell. The last section that we are reviewing from Chapter P to help us with the first section of Chapter 5 is Section P6, which is all about rational expressions, aka fractions with the alphabet in them. That's what I like to call those. Okay. So again, there are a few things here that are not too terribly important for what we're going to be doing in Chapter 5. So I actually looked in Chapter 5. I looked at every single problem in Section 5.1, and I didn't see any where multiplying and dividing rational expressions came up. For example, I did see a handful that had adding and subtracting rational expressions, so I kept that. Simplifying is very, very important, so we'll keep that. Okay. And then I'm going to make a confession, which is that the main reason I'm doing this specify the numbers that must be excluded is because it's a thing that my math lab, which is our current online homework program, is very hung up on. And so it's always going to ask you about these. But this part is not that important for what we're going to be doing in Chapter 5. It is important in calculus, though. So maybe for that reason, it's good that we're doing it. Okay, so again, when we talk about rational expressions, we're basically talking about fractions, except that instead of a number on top, a number on the bottom, you're going to have a polynomial on top and a polynomial on the bottom. And you'll see an example here in just a second. Now, of course, you remember that in a fraction, the denominator cannot be 0. In a fraction, right? Like 2 over 0, for example, that's undefined. Well, polynomials sometimes equal 0. So we have to be careful that the numbers that we're plugging into the polynomials are not making the denominator 0. Okay. So when they ask you about the domain of a rational expression, you're going to talk about the numbers that have to be excluded. All right, the numbers that make the denominator 0. Okay. So here's an example of that. And by the way, this is an example of a rational expression. 7x is a polynomial. It happens to be a monomial, right? It has one term. And of course, this thing on the bottom is a polynomial that's called a trinomial. So this is a perfectly good rational expression. They're asking me what are the numbers that have to be excluded from the domain of this rational expression. So again, what that means is find the numbers that make the denominator 0. The denominator is not allowed to be 0. Okay. So look at the denominator and factor it. Okay, because what we're really trying to figure out is when is this thing equal to 0? Okay, and you may remember that the easiest way to figure that out is by factoring. So if this thing is 0, that means that x minus 7 times x plus 2 is 0. Well, the only way that x minus 7 times x plus 2 could be 0 is if one of those factors is 0. I'm going to write this in here just because I think the way they wrote this up is a little odd, right? So when you set the product of two factors equal to 0, it means that one of those factors has to be 0. Either the x minus 7 is 0, in which case x is 7, or the x plus 2 is 0, in which case x is negative 2. So the two numbers that have to be excluded from the domain of this rational expression are x equals 7 and x equals negative 2. And just as an FYI, if they were to ask you what is the domain of this rational expression, you would say all real numbers except 7 and negative 2. Okay, so now we're ready to simplify some rational expressions. Just like with regular old ordinary fractions, like 15 over 25, the way that you simplify that fraction is by finding common factors. So the common factor for 15 and 25 is 5. So even though most people taking trigonometry at least do not think about it in this much depth, what you're really doing when you simplify a fraction is you're doing this. You're identifying 5 as the common factor, and then you're dividing out the common factor. Okay. Now let me talk about what you're not doing when you simplify a fraction. Okay. Of course, if somebody said to you, oh, I know how to simplify 15 over 25, you just cross out the 5s. No, I don't think so. All right. So that looks ridiculous when you do it with regular fractions, but unfortunately people don't think anything of doing it when it's an X or a Y. So that mistake, as ridiculous as it looks, I see it all the time, people doing the same thing when there's an X over here. That is just as bad, even though it doesn't look as bad. It's the same exact mistake. So when you're simplifying your rational expression, it's all about factoring. You have to factor everything and then get rid of common factors. See, these X's here are not factors. They are terms. Factored means written as multiplication, right? Okay. So let's look at an example. The example is, whoops, spoiler alert. Missed that one. X squared minus 1 over x squared plus 2x plus 1. So I am going to factor the top and the bottom. The top factors into x plus 1, x minus 1. The bottom factors into x plus 1, x plus 1, right? So now I see a common factor is x plus 1. So I'm going to get rid of the x plus 1 at some point. All right. This is always the part I look forward to. All right. Now, what they're saying is in the original expression, the denominator is equal to x plus 1 times x plus 1. So, of course, the number -1 is not in the domain of the original expression. Okay. -1 is not in the domain of the original expression. Okay. So, but when I simplify this down to x plus 1, x minus 1, and then I get rid of the x plus 1, it simplifies down to x minus 1 over x plus 1. And they have included mentioning this excluded value. Now here is where my math lab and I disagree. Here's the original expression. If you try putting -1 into this denominator, it comes out to 0. So the original expression is undefined when x is -1. But the simplified expression is also undefined when x is -1. So therefore, I, Mitchell, do not think that it's necessary to mention that x equals -1 is excluded, because it does the same thing to this expression that it does to this expression. So the only time that I think it's really important to mention the excluded values at the end, and this happens pretty often, is when that number makes the original expression undefined, but it's okay in the simplified expression. Then I think that you do need to exclude it. Okay. But when you're doing this on my math lab, just know that they want you to mention every single number that even made the original expression undefined. Okay. And we'll see more examples of that as we go along. Okay, so now we are into adding and subtracting rational expressions, and we're going to start with rational expressions that have the same denominator. If you think about regular old ordinary fractions, adding regular old ordinary fractions that have the same denominator is really easy, right? So if you have 3/8 and you add 1/8, you keep eighths. And the tired old cliche example of this is pizza, right? So I eat 3 slices of pizza, and the person I'm eating with only eats one piece. So together we've eaten 4 pieces of the original pizza. So that's still 8s. And then the only thing is, if it's possible to simplify your answer, you should go ahead and simplify your answer. So what I really did here was I identified 4 as a common factor. So this is 4 times 1. This is 4 times 2. And I've gotten rid of the 4s, right? So it works the same way with throwing the alphabet into the mix. You just have to remember everything has to be factored before you simplify, okay? All right, so let's look at an example. We're subtracting x over x plus 1 minus 3x plus 2 over x plus 1. So they have the same denominator. That makes this a pretty easy problem. Okay. So let's see, how did they do this? Oh, so the first thing they're doing is checking for excluded values. Okay, we can do that now. So this expression, the original expression, is undefined when x is -1. Okay. That value is going to be excluded. Now, since these two have the same denominator, that's easy. You just keep that same denominator. So here is the denominator x plus 1. Now this is very, very important. Okay. Upstairs, we are subtracting x minus 3x plus 2. We are subtracting the whole entire 3x plus 2. So you have to put parentheses around this 3x plus 2. You will get a different answer if you don't put parentheses there. So that is super important. Okay. When you distribute the minus sign, you're going to end up with x minus 3x minus 2. When you combine your like terms, put my spotlight back on, x minus 3x is -2x. And now, I think they rigged it this way. -2x plus 2 over x plus 1 is something that can be simplified, right? Because if you factor -2 out of the top, your other factor is x plus 1. You get rid of those x plus 1s, and you are left with just -2. Now here is an instance where I think that the excluded value does need to be there. Okay, so let me explain this again. The number -1 makes the original expression undefined, right? Because it makes the denominator 0. However, -2 is always -2, even when x is -1. So the number -1 does something different to this expression than it does to this expression. So the way that I think of this is we are saying that this expression, the original one, is 100% equivalent to the number -2, as long as you don't try it with x equals -1. Okay? So in order for them to be 100% equivalent, you do need to put that excluded value as part of your answer. Okay, so now we're getting ready to add and subtract expressions with different denominators. So of course, you know, even when you add or subtract fractions, if they don't have the same denominator, you got to make them have the same denominator. And the denominator that we usually choose is the least common denominator. So the way that we find least common denominator is factor all of your denominators. I can't emphasize enough that practically everything you have to do with rational expressions requires factoring. Okay. Now, they explain this a little differently than the way that I do normally, but they say list the factors of the first denominator, and then when you go to the next expression, you throw in any factors that you haven't seen before. Okay. And if you're adding 3 or 4 expressions, I think in this class we won't ever have to add more than 2. Okay. All right. So just throw in any factors that you did not see in the first expression, and that is your least common denominator. All right, once you have your least common denominator, then we go into the list of steps for how to add and subtract the rational expressions. And this really, it works the same way it does with regular old fractions. And I think that I'll maybe try to explain it that way, okay? So how many times has it come up that we have needed to add, for example, 3 pi over 8 and pi over 4? Okay. So the first thing I do is I find the common denominator, which is 8. Okay. And then in step 2, it says rewrite each rational expression as an equivalent expression whose denominator is the LCD. So the 3 pi over 8 is already over 8. So the only thing I have to do is multiply the top and the bottom of this one by 2. So that's going to rewrite it as 2 pi over 8. Okay. At this point, all of your expressions will have the same denominator. And so you just keep that denominator, add your numerators, and then, of course, simplify if you can simplify. 5 pi over 8, I cannot simplify. It's already in simplest form. Okay. So let's see how that works when everything is a polynomial. Okay. All right, so the example is x over x squared minus 10x plus 25. We're subtracting x minus 4 over 2x minus 10. Okay. So step 1, find the LCD. X squared minus 10x plus 25 factors into x minus 5x minus 5. 2x minus 10 factors into 2 times x minus 5. Okay. So the way that they explain finding LCD is you look at your first denominator and grab all the factors that appear in the first denominator. So I'm going to grab both of the x minus 5s. And now when I look at my second denominator, I see something that I have never seen before. I see a 2. So I'm going to throw that into my least common denominator. I don't need to throw in the x minus 5 because I already have one of those. I actually already have 2 of them. So I don't need 1. Okay. All right. So my least common denominator is 2 times x minus 5 times x minus 5. Okay, so now that we know that our LCD is 2 times x minus 5 times x minus 5, we need to write our expressions so that they have that denominator. All right, so for example, the first expression, x over x squared minus 10x plus 25, it already has x minus 5, x minus 5. So what you have to do is multiply the top and the bottom of that expression by 2. So this 2 is a new factor. Okay. And the second expression, that was the x minus 4 over 2x minus 10. So after we factored that, we have the 2 and we have one factor x minus 5. We just need another one. So this x minus 5 that you see over here, that is a new factor that got multiplied on the top and the bottom. All right, so now that we have our denominators the same, it's very easy to subtract the expressions. So here are the original expressions. And then when you have them over the same denominator, so they skipped one step that I would have written in here. This was the numerator of the new expression after we multiplied the top and the bottom by 2. And this thing over here was the new numerator of the second expression. Okay. So they've already gotten to the point where they're combining it into one fraction. Okay. So now, in order to simplify the top, you need to multiply out the x minus 4x minus 5. So you FOIL that. That gives you x squared minus 9x plus 20. Notice, and this is super, super important, that they kept the parentheses around the x squared minus 9x plus 20, because that thing is still being subtracted. After you distribute that negative sign over that trinomial, all the signs change. You get minus x squared plus 9x minus 20. And then you combine your like terms. 2x plus 9x gives you negative x squared plus 11x minus 20. All right, we're just about done with this problem. So on the last slide, we got it to this point. So the difference between these two expressions comes out to negative x squared plus 11x minus 20 over 2 times x minus 5 times x minus 5. So now I just have to try to simplify that. It turns out, though, that this numerator is prime. There is no way to factor that. Easiest way to see that is first factor out a negative 1. You factor out a negative 1, it leaves you with inside x squared minus 11x plus 20. So the way that I would normally try to factor a trinomial like that is find two numbers that add up to negative 11 and multiply to 20. And I can't think of any two numbers that do that. All right, 1 and 20 doesn't work. 2 and 10 doesn't work. It's close. I can get negative 12. I can't get negative 11. And 4 and 5 doesn't work. That would give me minus 9x. So because I can't factor this numerator at all, this expression is already in simplest form. And so they're writing the answer like this, and they are putting the excluded value. This is another one of those situations where I don't agree that it's necessary to exclude x equals 5. X equals 5 already makes both of these expressions undefined. It does not do anything different to this expression.